Hello and welcome to week 3 of Operations Research 2. Um, so this week we're going to talk about decision trees, how to incorporate utility theory, knowledge that we have into decision trees, and then finally, and some new concepts in the decision trees such as EVSI, EVPI, and which are very important. And then Bayes' theorem. Okay, we will learn about all of these, but these are four main topics that we're going to discuss today. So let's just start with an introduction to decision trees. So trees are tools that help us break down complex decision-making problems that involve a series of decisions over time. For example, I want to let's say I want to buy a new car, right? And I'm deciding between not buying a car or renting, buying let's say a Chevy and buying a Tesla, which is an electric vehicle. All right, so these three alternatives, I'm deciding between these. So which car I get, if I decide to purchase a car, um, I would like to purchase a Tesla if my job is going to be in California, right? Otherwise, and I have to buy the Chevy. And whether I purchase a car or not itself depends on whether I can get a job. All right. So the first thing that I'm not sure about is whether I get a job. And second thing is where that job is going to be. So these two are happening consecutively uh, on a planning horizon or over a period of time. And I'm deciding, and depending on what happens, there are some uncertainties involved. I'll make a decision. So decision trees help me formulate these and structure my thought with a decision tree on a tree, and then use the backward method to choose the best decision based on the probabilities that I have for getting a job, for the location of that job, and all of that. All right. So let's learn some notations that we're going to use a lot for decision trees. The first one, we call them event fork. So event fork, we use a circle and there are some events coming out of it. And then we put probabilities on these, P1, P2, and we want the sum of all of these probabilities to be equal to 1. So events are things that happen just like states of the world that we had in decision criteria. Um, these events are outside of our control. So outside of our control, similar to states of the world, right? So don't forget that. We show this with circles. Let me make it as close to a circle as possible. And then we have decision forks. Decision forks are things that we choose. So we have a number of options. These branches are options. And we are going to mark one that we choose as our decision. So from these branches, each one of these represents a different decision. And the one that I choose, um, I will mark it. So a decision tree is basically a network of all of these events and decisions that we put in a consequence, that we put in a network of um, event forks and decision forks. And these are terminal branches, things that uh, come out of them. The ones that are at the end, let's say my decision tree starts like that and it keeps growing, right? At the end, you have some uh, branches that you don't have anything following them. So those are called terminal branches. Okay. And there is a method that I call backward method because we start calculating everything starting from terminal branches backward to the initial to the beginning of the tree, and because of that, I call it just backward. This is has this orientation, and with this backward method, we will choose the best sequence of decisions. All right, and so just note that I put the probabilities on event force, not decision force. So whenever in this backward method, I'll be calculating a lot of expected values. I calculate expected values only on event force, not on decision force. Okay, just have that in mind. For example, I have a value at the end of this branch, $20. I have a value here, $40, and there are some probabilities 0.2, zero point 0.8. I calculate the expected value 0.2 times 20, which is 4, plus 0.8 times 40, which is 3.2. And then some of those, sorry, 32, some of those will be uh, put here. All right. For example. All right. Let's start with an example from your book. So there is a company called Cola Co. Apparently, they produce colas. So right now, they have an asset position. They have $150,000 put aside for something. And you can pause at this point and read this part, which is the problem description here at the bottom. All right. So this company tries to launch a new product that's a chocolate flavored soda, and they call it Chocola. All right, it's a funny name. They're trying to market this product, and there are some information given to us. For example, they can do a test marketing. For example, they can do it here in LA to test it to see if it's successful or if it's a failure, this new product. If it's successful, then they can go national, right? Or if it's not successful, then they can choose not to market it further. Or it may be unsuccessful here in LA, but successful nationally. So, and there are some probabilities for each. So what decisions they have, what alternatives they have? That's the first question. In the example I gave in the previous slide, my options were to not buy a car, buy a Chevy, or buy a Tesla, right? Here, the alternatives are alternative one, test market Chocola locally, then utilize the results of the market study to determine whether or not market Chocola nationally. Alternative two, immediately market it nationally. Alternative three, immediately decide not to market it at all. All right. So these are my three main options. Each one has a different, what is it? Has a different cost associated with it. So I'm gonna take those costs out, and I want to put everything that's given to me on a decision tree. So I'm gonna go to the next slide and draw that. So hopefully by now you have read the problem description. So it starts with the first decision I want to make is whether I should market it. So because I want to make a decision, this is not an event. It's something that I choose to do. I start with a square. So market it locally or don't market locally. There are no probabilities on these branches because it's a decision. I can choose that. And if I don't market it locally, then I have two options, alternative 2 and 3. And one is market it straight uh, nationally, or don't market it nationally. So on this branch, I'm basically, so these are my three main alternatives: market it locally, market it nationally, and market it, or sorry, don't market it. All right. And if I don't market it, nothing happens after this. So my nothing happens to my asset position, which is $150,000. I still keep that. I didn't spend money on anything. All right. But it said if you market it, if you market it nationally, and if it's a success, you're gonna obtain uh, $300,000, right? And if you lose, I mean, if it's not successful, if it's a national failure, you're gonna lose $100,000. All right. So from this point on, it's out of my hand. Okay. So there is an event. If you don't market it, nothing happens. You just didn't do anything. If you market it nationally, two scenarios are going to happen. So I draw a circle here. One, it's a national success. Two, it's a national failure. And also the probabilities were given to me. One was 0.55, one was 0.45. All right. So these are terminal branches. After this point, there is nothing else I can do. Just like this one where I put the 150K. So national success. I had 150,000 initially, right? And I gained 300,000. So I will have a total of $450,000 here. Here, I marketed it nationally, but it wasn't successful. It was a national failure. So from the 150K that I had, I lost 100K. So now I have left with only 50K. Okay. Now, let's go to the other main branch. In this scenario, I'm going to market it locally. All right. So what happens after I market it locally? It's going to be either a local success or a local failure, right? So it's out of my hand. I can't do anything about it. I don't have any control over it. So it's going to be an event fork. So it's going to be local success or local failure. If it's a local, and also in the information here, you can see that local success is 60% likely, and local failure is 40% likely to happen. So that's 0.40, 0.60. Some of them is 1, just to check. So what can I do if it's a local success? If it's a local success, I still get to choose to market it nationally or don't market it nationally, right? So this entire branch on top will repeat here. So again, but with different probabilities: market nationally and don't market it nationally. If I market it nationally, if I don't market it nationally, all that happened is the money, I lost the money that I spent on marketing it locally, which was 30,000. So I had 150,000 initially, and I lost 30,000 of it. So I have 120K left. So here it may sound like a stupid decision, something that common sense says if you're gonna market it locally and have a success, why don't you go nationally? But we want to include all the options, all the possibilities here, and let the method or algorithm decides which course of action is the best. And if I market it nationally, again, there is a chance that it's a national success or national failure. And and I've been told that with the product, if it is a local success, which is the case because we are on this branch, and you go market nationally, there is the chance that it will be successful also nationally. It's 85%. If it's locally successful, the chance that it is national failure is only 15%. All right. So if it's a national success, initially you had 150,000. You spent 30,000 marketing it locally, and then and then you gained 300,000 by being a national success. Now you're left with 420,000. Okay. And if it's a national failure, it's the worst. You had 150, you spent 30K for local, and then you also lost 100K for national failure. So now you're left with only 20K. This is probably definitely the worst case. All right. And if you have a local failure, so let's say you go market it in LA and it's unsuccessful, which happens 40% of the time. If that's the case, you still um, get to choose to market it or not. So market nationally or don't. All right. You still get to choose. If you don't market it nationally, playing it safe, you say, okay, I had 150K, I spent 30K, and I'm not gonna continue, I'm not gonna risk, I'm gonna keep my 120. In the other case above it here, uh, although you were successful, you were kind of skeptic about the whole thing, and you decided that your success in LA wasn't uh, uh, trustable, maybe. So you decided not to go nationally, although you had these probabilities. We want this decision tree with the backward method. We will see how all of these probabilities, all of these values work together to let us know what is the optimal decision. So if it's locally a failure, and then you decide to go market nationally, then again, it may be a national success, it may be a national failure. The probabilities here are different. Uh, we are told that if it's a local failure, the probability that it's going to be a national success is only 10%. And if it's a local failure, the probability that it's going to be also a failure nationally is 90%. Where do I get these? In the problem description here. Here. I am assuming that you had paused the video and read the description, so you're familiar with it. Problem description. So if it's a national success, again, just like the one above it, you had 150 in the beginning, you spent 30K marketing it locally. Despite being unsuccessful there, you were successful nationally here, 300K, and you're left with 420K. And if it's a failure, 150 minus 30 minus 100K, so you will be left with only 20K. All right. So far what we did, we put all the information, all the problem description on a tree. So this entire tree and all the numbers on it is the same as this description here down at the bottom of this slide. All right. The only difference is that this text here is a little confusing, but this is very organized and we can think clearly looking at this. First, we have two options, going locally or marketing it locally or not. And if not, we can market it nationally or uh, give up. And if we not market it locally, two things may happen. You will be successful locally or failure. And despite, regardless of what the result of local marketing is, you can still get to choose to market it nationally or don't, right? And those are probabilities of what's going to happen if you do that. All of those are given to you. And we have also calculated the values of the consequences at terminal branches. So that's the first step. Draw the tree, put the values on final branches. I did that. Now we start the backward method. Okay, you start the backward method. You may pause at this point to see if everything makes sense to you. Next, I'm going to present the backward method.